Watch your forks. Today we're solving Sum Trail Through the Fork by Megan033. The rule set is as follows. Normal Sudoku rules apply. We have fork, so correctly placed digits will clear the fork around that cell. No guessing is required. Regional blue sum line. There's one and only one blue sum line where box borders divide the line into segments of equal sum. Distinct segments of the line within the same box count as separate sums to the same value. We have kilocages and KROPKis. If you want to try this Sudoku, hit the first link in the description. If you just want to watch my solving attempt or need clues for yours, let's dive in and unravel this. So here you can see the grid is mostly covered in these fork cells, and we only are able to start with those cells that are cleared of fog already. So, and we do see like the KROPKis, we have one kilocage and like these blue regional sum. And this one goes down, this one goes to the left. So this is the same blue sum line because we only have one in this Sudoku, but both have the same value. So this and this is the same value. Now what we can do, if we put in the KROPKI with a 2-to-1 ratio, this could be 1 and 2, 2 and 4, 4 and 8, and 3 and 6. Now, keep in mind, this has the same sum as those 4 cells. The minimum amount, like value we could put in 4 cells is 10. If we put in 1, 2, 3, and 4. That means we can't have a 1 and 2 pair in here. We can't have a 3 and 6 pair in here because that's only 9. So we do know this definitely is a 4 and 8 pair, which add up to 12. So we already know the regional sum line, each segment is 12. That means we cannot have 4 in here because it's in this pair. So we do have a 5 in here. Now the numbers add up to 11. So we need one more. 5 is the only number in here which can be increased because we can't increase 1, then we would have 2 2s. We can't increase 3 because the 4 is already occupied here. So no 5, but a 6. So now both regional sum lines add up to 12. Now, these two needs to be consecutive. So neither of those can be a 6. And we can fill in the missing digits in that box. 1, 2, 3, 4 taken, 5, 7, and 9 are missing. So if we put 9 and 7 in this cage, we would already have 16, which is more than the 15 in the cage. So we do know 5 is definitely in here, not in here. One of those definitely is 5. 5 and 9 would be 14, which is also too high to get to 12. So this is also not 9. This is a 5, 7 pair, giving us the 9 in here. Now this is 12. Bullshit. Now I got confused with the regional sum. We don't need to, we can have 5 and 9, which add up to 14 if we have a 1 in here. We can have 5 and 7, which is 12 if we have the 3 here. So the 2 cannot be in here, which means this definitely has to be the 2. Yeah, and now the fog, this digit is correctly placed, so now we got more of the grid to see. We can pencil mark here. This can be also 2, 4, 5, and 7 to be consecutive to every option in here. The 9 can be made out of a lot of options, of course. We're going to put them in all. It's 8, 1, 7, 2, but only in a specific order. It's 6 and 3, and oh, sorry about that. 6 and 3, and 4 and 5. Now we do know that this is definitely 3 cell. It needs to be 4 cell. Can go like this, can go like this, but it also could go like this. So even more. So that does not help a lot. Let's check for this KROPKI. We can't have a 1 and 2 or 2 and 4 pair. So this could be a 4, 8 or a 3 and 6 pair. But if we would put in 3 and 6 in here, those two cells only have the value of 1 left over, which is not possible. So no 3 and 6 in here. That's a 4, 8 pair, giving consecutive 3, 5, 7, and 9. Now, if we put a 9 in here, we would have at least 3 more cells for the regional sum line. 9, and the minimum amount for 3 cells is 6, so 15. That's not possible. Same with 7, 7 and 6 is 13, so 1 too high. So that's 3 or 5, leaving the 8 out of here. And this needs to be the 4, then 8 in here. No 4 here means no 5 here. We get to 9. And now we see this is a regional sum line we're looking for. White KROPKI, so consecutive numbers. We can't add a 1 because 2 is taken. 3, no, because 4 is taken. It could be 5, 6, 7. That's consecutive with 5, 6, or 7 because 8 is taken and 9 would not fit in there. So one of those definitely is the middle digit, which is 6. Means no 6 in here, giving us the 6 in this digit cell. And we have a 1, 3 pair here. 6 is ruled out, so this is not 5 and 7 anymore. This could pencil mark it, but there is definitely the 9 in there. And then, of course, 5 or 7. 9, 9, 5, 7. Let's have a look at this regional sum line. If this would be a 3, we still need 9 more in those 3 cells. Which is, for example, 1, 2, and 6. Can't put a 6 in here. Okay. Let's screw this for a moment. The 5 we marked here is looking at this. So we got a 3 in here. So now those definitely need to be 9. Um, 9 and 3 cells is 1, 2, and 6. That would be a 1, 2 pair. This would be the 6. Yeah, it could be. Is there any other option? 7, 1, 1, of course not. 6, 1, 2, we all got that. 5, 3, 1, not possible. 5, 2, 2, not possible. We already got the 4. So I think 6, 1, 2 is the only option to get to 9 in that box. When 4 and 8 is taken, 7 is too high. We would need 2 ones in there. And 5 would need a 3 with a 1 or 2 twos. Yeah, okay. So we can place the 6 in here. Now this is a 6, correctly placed. Can get rid of the pencil marks. No 6 in here means no 3 in here. And we erased another 1. The 1 got the 8, 2, 7. 5 got the 4. This 6 in here doesn't have a 3 anymore. Should have erased that a little bit earlier. Now let's check here. What are we missing? 5, 7, and 9 in that box. Now we need 5 in here, which is 4 and 1 or 2 and 3. Can this be 4 and 1? If we have 4 and 1 in here, this needs to be an 8, which needs a 1, can't be, or a 7 in here, which we needed 2 in here to add up to 9. Then this is not possible. Okay. So if this is a 4 and 1 pair, we would need 7 or 8 in here, and 7 needs 2 and 8 needs 1 to get to 9 for the killer cage. But then we got 4s and 2s definitely taken. So this cell would have no valid option. I hope that was understandable. So this is not 4, 1. That's 2, 3, giving us the 4 in here correctly placed. 4 is only consecutive to a 3. No 4 in here means no 5 in here. 2 and 3, no 2 in here means no 7 in here. Giving us a pair of 1 and 8. 9 could be 1 and 8, but we already got 1 and 8 in here. So 7 and 2. 6 and 3 can't be because this cell can be neither. And 4, 5 can't be because we already got 4 in the box. So that's a pair also. Okay, let's see. If this is a 9, we need to get to 3 to get to 12. We can't put a 3 because of this 3, so this is not the 9. We got a 9 in here. This is not the 3. If that's a 7, we need to have a 5 here, which is possible. It is not, because this 5 looks to the right, giving us the 5 in here and the 7 in here to get to the regional sum 12. 7 also in here. 7 is root of those, out of those. 7 is here. There's a 2 and a 7 here to see all of this box. And then we can complete the pencil marking of the row, which is 4 and 8. And maybe of this row, which is 1, 2, 3. Can we do anything with this consecutive KROPKI? We can't put a 1 in there, no 2, no 3, no 4, no 5, because 6 is taken, so 7. The only option it would be 8 and 9 as a pair for those two. 8 and 9 already is 17, so if the box would go like this, we need a 1, but there's a 1 already here, so the box needs to go down, giving us the 1 to get to 18. And the last missing digit is the 5 in that column. Let's check for this KROPKI. Can't be 1 and 2 pair, but 2 and 4, just like oh no, can't be 2 and 4 because this cell sees those two. So also no 4 and 8, so this is a 3, 6 pair. Now, if that's an 8, we need 4 in here, which could be 3 and 1, but not 2 and 2. So if that's an 8, this is 3 and 1. And that's 8, 9, 6. This would be automatically be the 5. If that's a 1, we would need 11 in here. 11 is 9 and 2, not possible. 8 and 3 could be. 7 and 4, not possible. And 5 and 6, I think that's still possible. So this is no 1, no 2, it could be a 3, no, 3 is in here. 5, 6, 7, 8, or 9. Okay. Now if we continue this regional sum line, we don't know if it's maybe also going down here or back up again. So if that would be the 6, and it's only one cell, we would need another 6, which is not possible. So if that's a 6, we need to have at least, we need to have like 2 more cells for the regional sum line. If this is a 3, we would need 9 in here. 9 is possible to then go into the next box. Okay, but this pair is looking at this 8, so no 8 in here. This 5, 9 now is a pair, so this is 4, 8. Oh, and 2 is missing. One of those definitely is a 2. Okay, so let's have a look again at the 6. This definitely can't be a 6. It needs to be a 2 cells at least if this is 6. We cannot have 5, 1. We cannot have 4 and 2 because the 2 is definitely in here. And 3, 3 is also not possible, and we can't have all 3 digits. So this is definitely not a 6. That's the 3, that's the 6. Oh, and now we see it's going straight out, so we need to have the 9 to get to 12. 8, 9. In this box, we are missing 7, 6. 2 and 4 as a pair is giving us the 8 and 4 in here. 8, 3, 1, yes, or 1, 3, 8. Okay, that does make sense to get to 12. 3 is definitely in one of those. Let's check for the 13. If this is a 6, we still need 7 in here. 7 can't be 6 and 1 because of this. Can't be 3 and 4 because they are already here. So it would need to be a 5 and a 2, 2 to add up to 13. 6, 5, 2. If that's a 7, we need 6 more in here. It can be 5 and 1. 6 more. It can't be 3, 3. It can't be 4, 2. Oh, okay. So we do know this is definitely a 5. We still need to figure out if it's 6, 2, or 7, 1 in here. Now here, 10 is 9 and 1. Can't be 8 and 2 because of this 8. Can't be 7 and 3 because of this. Could be 6 and 4, but we have 4 and 6 in that column. So this is 9 and 1 because 5 and 5 obviously never go in a killer cage with those rules. Now, we still don't know if it's just like a, oh, okay. Yeah, if it's like a 3 cell sum line, or it maybe goes up and another one up. We don't know that. Yeah, but we do know that like 4 as maximum can't go in 5 cells. So what's missing in that column? Quite a lot, because that's not working out to eliminate some numbers. I'm gonna pencil mark them anyway. So 8, 9. We still need a 7. Oh, and is this the only cell for that column fit in a 7? Yeah, I think. So that's a 7, yeah. 9 can never be on a black KROPKI because there is no valid half of it. So that's 8 with 4 next to it. Now we can solve those cages. 9, 1, 2, 1. And we see, okay, And this is 3 cell, and this actually is a 3 cell plus another 2 cell. So I think we go with a 2 cell first. 9 and 3, not possible. 4 and 8 could be possible in this order. 7, 5, not possible. We have a 5. 6, 6, also not possible. So we do know that's 4 and 8, giving us this needs to add up to 10. 9, 1, not possible. 8, 2, no. 4, 6, no. But 3 and 7. We do know the order already. And the last missing number is 6, giving us 6 and 7 in here. Let's check if we can do the same with this. It could be 9 and 3. 3 and 9 in this order. 8 and 4. 8 and 4 in this order. 7 and 5, no, because 7 is on top. And 6, 6, of course not. Okay. So we need 8 in this. And those two cells can't have 7 and 1. We could have 6 and 2. No, because this cell sees a 6 and a 2. 3 and 5. But we do know the order. 3 and 5. And not another 4 and 4. Okay, so this is actually the 5 and the 3. 3 and the 1. We still need a 2, which is in here. 3, 4, 5, 6, which is also in here. But this and this giving us the 6 in here, the 2 in here. The 9 is missing, giving us 9 and 5. Now we can complete this row. 1, 2, 3, 4, 5, 6, 7 is missing. What's missing in here? 1, 2, 3, 4, 5, 6, 9. 9, 6. And for the box, 1, 2, 3, 4, 5, and 6. Oh, and this has enough constraints to be placed. Well, sorry about that. 4, 5. Okay. Not a 6. 6 is in this row. Sorry about that. 9. 9. This still is a 4. This is a 5. 9 is also there. Okay. Whoa, what am I doing? We have 1, 2, 3, 4, 5, 6, 7, 8. It is. Okay, a little bit of embracing. A little bit embracing. Embarrassing. Close enough. Good. So we fixed that row. Let's concentrate a little bit better on this one. We got 1, 2, 3, 4, 5, 6. No 6 in here, no 5 in here. Let's have a look if this can be a 9, because 9 and 4 is already over 12, so this never can be a 9. 8 and 2 and 1 would need another 1 in here, so that's not an 8. So the minimum we can put in those cells is 4, 5, 6, 7. Okay, yeah, so same goes for this 8. 8 and 4 is too much, so there can't be an 8 in here. So this is the 4, this is the 5, 8 in here. 8, 4, 5. When my fingers are faster than my mouth. Okay, now the regional sum line is already solved. So we just need 1 in here, 2, 3, 4, 5, 6, 7, and that's the solution. I hope you enjoyed it. See you next time.